Today our topic is similar figures and scale drawings. So our essential question is, how can I use proportions to solve problems that involve similar figures and scale drawings? First off, some vocabulary. Similar figures are images that have the same shape but are different sizes. So an example of that could be a square, where we have one square that's that size, but then we have a square that's bigger. They're similar, they have the same shape, but they're a different size. Scale drawing. Scale drawing is a enlarged, which would mean bigger, or reduced, which would be smaller, drawing that is similar to an actual object or place. Examples of that would be a map. A map is a smaller sized version of the real world. A building, sometimes we draw a model of the building before we draw the big one. Blueprint, so before they build a house, they draw up a blueprint of it, which is a smaller drawing than the actual thing. And then the scale. The scale is the ratio of the original size to the scale drawing. So down here, if you look at this map, it's kind of the map of the United States. Here's Florida. It's the bottom half. Here's Texas. And then you have this map scale, and it's telling you that for every inch, so for every section that's that long on the map, it's actually in real life 1.576 miles. So that's the scale, because we had to bring it down. We can't fit a map of the entire United States at real size, so we scale it down. Similar figures. The following rectangles are similar. Find the missing length. So for similar figures, they are proportional. We learned about proportions in our last set of notes. So to set up our proportion, we can do small dimension to big dimension. So on the top, we'd put the small dimension. On the bottom, we put the big dimension. So if we look here, we have our small size, 3.2. What corresponds to 3.2 on the big one would be 4. See, they're the same spot. So we have 3.2 over 4 equals the other dimension on our small rectangle. This would be the small rectangle because it's smaller than the big, is x. We have x unknown. And in relation to that is 7.5. And then it's a proportion, so we can solve by cross multiplying. For cross multiplying, we multiply our diagonals. So we do 4 times x, and we get 4x. We do 3.2 times 7.5, and we get 24. Solve that for x, so we need to divide by 4 because this is multiplying. Undo that with division. We get x equals 24 divided by 4 is 6. Now this is a dimension, so we need to put the dimensions. They were all inches, so x equals 6 inches. We do need to have that unit there because it is a dimension. It is a length. A tree casts a shadow 10 feet long. At the exact same time of day, a 5-foot woman casts a shadow of 4 feet long. Draw a diagram and use a proportion to find the height of the tree. So here we have a tree. This is a tree that's some dimension tall. We don't know how tall it is. That's what we're trying to find. Find the height of the tree. But we do know that it casts a shadow of 10 feet long. So shadow right here, we'll say that's 10 feet. Then we know that at the exact same time of day, so when the sun is at the same position, a 5-foot woman is 5 feet tall. And she casts a shadow of 4 feet. So her shadow is only 4 feet. Use a proportion to find the height of the tree. So we can have woman dimensions over tree dimensions when we set up our proportion. Because remember, we need to set up a proportion. So one of the woman dimensions was 5 feet, so we can put 5 feet right here. The corresponding tree dimension would be x, so we would put x. On the other one, we have a woman dimension is 4 feet. And then on the same spot for the tree, that shadow is 10 feet. Solve the proportion by cross multiplying. We multiply one diagonal, we get 4 times x is 4x. Multiply the other diagonal, we get 5 times 10 is 50. Divide both sides by 4 to get x by itself. When we do 50 divided by 4, we get 12.5. Now remember, it needs to be a dimension. All of them were feet, so we need 12.5 feet. We need to add the units on there, have feet on there. Scale drawing. An architect designed an apartment building that was to be 196 feet high. It's pretty tall. He made a model of the building using a scale of 1/2 inch to 1 foot. How tall was the model? So we are going to set up a proportion. Now right here, this scale is a ratio. So that can be written as a fraction. We have 1/2 inch to 1 foot. 1/2 inch over 1 foot. However, we can't have this as 1/2. I mean, we could, but it'd be more difficult. So 1/2 as a decimal is 0.5. So let's write that as 0.5 inches to 1 foot. And we know that the apartment building was to be 196 feet high. So we have 196 feet right here. Because we have feet on the bottom, so we'll put feet on the bottom. We want to know how tall was the model. How tall is this guy right here? So now when we solve this proportion, we'll find out in inches how tall the actual model was. So cross multiply, we need to do 0.5 times 196, and we get 98. And then we do 1 times x equals 1x. Divide both sides by 1, x by 1. And we get x equals 98 inches. So the model of the building would be 98 inches tall. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.